Hello guys, in this video I'm gonna give you one of the fundamentals of electric circuits or electric circuit analysis, which is basically the short circuit, the concept of a short circuit. Okay, this is we can say ideally it is like a very scientific term. It's not practical. It's a very ideal condition of a wire. So basically, a short circuit, as I said, is a wire. Okay, or something that has like zero resistance. So we have any short circuit have 0 ohms, zero resistance. Okay, that's one of the fundamentals of a short circuit. Another two like notes here or observations here. Any short circuit is basically one point, one node. Short circuit is one node, or we can say point. So even if you see it as a wire, something long, it is basically one node. So that's a kind of manipulation that we can do to make like the circuit looks easier to understand or looks easier, to analyze. So we can extend it, make it like a wire. We can short it, make it like a node, or we can shape it in any shape we want. Like for example, here we have what appears to be two nodes, V1 and V2, although they are actually one node. Okay. So V1 and V2 here are part of a wire. Wire in electric circuit on paper is zero resistance. So that's actually one node. So all of this can be reduced to one node. And this node, you can call it whatever, V1, V2, whatever you want. It is just one voltage. So, for example, let's assume this short circuit is something real that we can touch and measure in the lab. If I, ask you to measure V1 and V2, you should give me one number, because V1 is equal to V2, is V2. They are the same, just one node. And whatever the shape that this wire takes, as long as it's a short circuit, zero resistance, you can shape it in any form you want. You can make it oval like this. Still, V1 equal to V2. Let's call it V. It is one node. One node like that. Okay? Long or short. Like short in length or long in length. Whatever. Still, V1 equal to V2. Let's call it V. This can be reduced to one node like that, called V. You can make it a rectangle like this. Still, V1 equal to V2, and still you can shape that into one node called V. You can make it like, I don't know, hazy like this one. Still, V1 equal to V2 equal to V, one node. You can make it triangle like that. Still, V1 equal to V2 equal to V. So again, no geometry here. No geometry. In electric circuits, geometry here is like straight, or like a circle or like a rectangle. That doesn't count for us. That doesn't. What count for us? Who is connected to who? That's it. Okay. And what is the resistance? And if the resistance is zero, short circuit, that means the shape doesn't matter. We can manipulate, or make it long or make it short, draw it as a rectangle, draw it like as a wire, curvy, whatever. It is basically short circuit. It's just one node that we elongate. I mean, if you have a circuit, like this, if you have, like, for example, a resistance connected to another resistance, R1 and R2, all that in between is short circuit. So this same circuit can be drawn like that. R1, R2. It's still the same. Can be drawn like that. R1, R2. It's still the same. Doesn't it change? This will not affect the voltage of that node. Remember, it's 1 point. You can make it like that. Very long. Still, same. It is still same 1 point, short circuit, zero resistance. One might say, yeah, we studied in chapter 2 that the resistance, depend on the length of the wire. Yeah, but this is a short circuit. That's why it is on paper. It is a concept on paper, not in the lab. You will not find in the lab something with zero resistance, of course. Even your wire, even if it's very thick, it will be approximately zero, but not ideally zero. This guy here, short circuit, is ideally zero. Okay? And whatever its length, still L is equal to, I'm sorry, resistance is equal to zero. Okay? That's why we can shape it in whatever shape we want. Okay? So, if I say for you, this point is called V1, and this point is called V2, this point is called V3, this point is called V4, you have to say for me that V1 is equal to V2 is equal to V4 is equal to whatever, let's call them V, and they are just one node. I mean, you can draw R1 and R2 like that. This is R1, this is R2, and let's assume this is just one node here, called V. Okay? That's very, very important. Very important concept because it causes a lot of confusion, especially that you studied that R is equal to rho L over A or L over A sigma. Okay? So the geometry is still in your mind. This was my case as well. But when we analyze the concept of a short circuit must be in your mind. And again, same voltage and ignore the geometry. As long as it's a short circuit, whatever geometry, we ignore that. Okay, all these that I just draw here are equivalent, are the same actually. Okay, guys, that was our introduction to short circuit. Thank you very much for watching and see you in another video. Bye-bye.